In this video, we're going to talk about the angle triangle sum and how you can find the measure of a third angle in a triangle if you're given two other angles. Before we get into that, we're going to do a little review of the different types of triangles. And there's three ways that you can classify a triangle by its sides. Okay, so if all the sides are different lengths, and that's what those three different tick marks mean, we call that a scalene triangle. If you have two sides that are congruent, that's what we would call an isosceles triangle. And there's no E on the end, but there is a special name for the point here where the two congruent sides meet. We call that the vertex of an isosceles triangle. The last type is where you have all three sides congruent, and that is what we call an equilateral triangle. Okay. Now, on the other hand, there's four different ways to classify triangles by their angle sides. Okay, so if we have a triangle with angles degrees of 30, 70, and 80, those are all less than 90, which if you remember from earlier, those are called acute angles, so we call that an acute triangle. If you have a right angle in your triangle, we just call that a right triangle. And then if you have an angle that's over 90 degrees, for example 120 degrees, if you remember from previous chapter, that is an obtuse angle, so we call that an obtuse triangle. And then lastly, if all three angles are the same measure, we call that equiangular. Okay, so let's just practice sketching a triangle given some info about it. In your first example, it says to sketch and properly mark and label the described triangle. So in number one, we're going to sketch an obtuse isosceles triangle ABC with the vertex angle C. So let's start with an obtuse angle, and then we're going to create a triangle on the bottom. And let's say this is anything over 90. I'm going to say this is a 100-degree angle here. And then we have to make sure that we mark two sides as congruent if it's isosceles. And then lastly, we want the vertex angle to be at C. And remember, the vertex is where the two congruent sides meet. So if that's C, these two down here, those two vertices have to be A and B. Okay. Now moving on to number two, we have an equilateral, equiangular triangle DEF with a perimeter of 12 centimeters. So if it's both equilateral and equiangular, we know it has all three angles congruent. We're calling it triangle DEF. And then since its perimeter is 12, if I would divide that by the three sides that I would have, that would tell me that the side lengths all have to be 4 centimeters because we know it's equilateral. And 4 plus 4 plus 4 would give us that perimeter of 12 centimeters. Alright, now we're going to move on to something a little bit trickier. We have this triangle PQO, and we're going to classify that by the number of sides that it has. Well, in order to do that, we need to figure out how long each side is. So first, let's see how long is this side here, PQ. And to do this, we're going to use the distance formula that we learned back in chapter 1. So the length of PQ, what we're going to do is take the difference in our x's, which in this case is -1 and 6. We're going to square that. And then we're going to add to that the difference in our y's, which from P to Q is 2 minus 3. And then we're going to square that. And then at the end, we're going to take the square root of that entire thing. Okay, so if we simplify that a little bit, -1 minus 6 is -7 squared. 2 minus 3 is -1 squared. Don't forget, we're going to take the square root of that entire thing. So -7 squared is -7 times -7, which is 49. -1 squared is -1 times -1, which is 1. And then we're going to take the square root of that. Well, the square root of 50, if you plug that into a calculator, it's going to give you approximately 7.1. Okay, now let's go ahead and do that for the other two sides. Let's do PO, this side over here. So using that same formula, first take the difference in your x's, which in this case is -1 minus 0, square that. And the difference in your y's, 2 minus 0, square that. And we're going to take the square root of the whole thing. Now, since we already went through PQ piece by piece, if you just plugged this all in, you could probably do some of this math mentally. You're going to end up with 5, and the square root of 5 gives you approximately 2.2. Lastly, we need to look at this third side, side QO. So, again, using the distance formula, take the difference in your x's, so in this case 6 minus 0 squared, plus the difference in your y's, 3 minus 0 squared, and square root that. I can see that that's 36 plus 9, which would give you the square root of 45, and that is approximately 6.7. Now, if you notice, these three sides are all different. Well, if all three side lengths are different, that means this has to be a scalene triangle. Okay, now let's look at a couple of theorems. These are your first two theorems in Chapter 4. You've already learned Theorem 4.1. We call it the triangle sum theorem, and that just tells you if you take this angle 1, 2, and 3 and add them up, for a triangle, the three angles always add up to 180 degrees. Okay, very common theorem. Probably seen that before. Theorem 4.2 is a little bit different, and you might not have seen that one before, but that has to do with what we call an exterior or outside angle. So it turns out that if you know these two angles that don't touch this outside angle 3, if you add up the measure of those two non-adjacent angles, they will equal that exterior angle over there, angle 3. Okay, and we're going to look at an example of each of these theorems down below. Okay, so first of all, in example 4, we have all interior angles. Well, we know that symbol there means that this is a 90-degree angle. So what we can do is take all three interior angles, add them up, and set them equal to 180. If we simplify that, we get 2x plus 90 equals 180. So if we subtract 90 from both sides, we get 2x equals 90. And dividing by 2 would give us x equals 45. All right, and your last example deals with Theorem 4.2. Now remember, that one tells you that if you add these two angles that are non-adjacent to angle y, they will equal y. So y is just 70 plus 88 degrees, which is 158. Now a second option to figure out this problem would be to use that triangle sum theorem. So we know that this angle here would be 180 minus these other two angles, 70 and 88. And if you did the math there, you would end up with 22 degrees for that acute angle down here. All right, and now if you know that's 22, well, this here, angle y, is a linear pair to 22. So if you did 180 minus that 22 degrees, you would still end up with y equals 158. Okay, so there's two ways of looking at this problem. This is a little less work, but if you don't remember that theorem, you can just use the fact that you know those three triangle angles have to add up to 180. All right, so your task after taking these notes is to summarize what we talked about here And then there is a worksheet on the table up front that you need to complete by Friday.